Hey guys, another chapter 6 section 3 video here for you. Today we are going to work on what are the important features of an exponential graph. So we're going to get into what are some key features and characteristics of exponential graphs. And to kind of kick things off here, here's what we're going to write down. Exponential functions are always in this format. Y equals b to the x power. Now b is actually a number, so it's like y equals 3 to the x or y equals 5 to the x. And we refer to it as b because we like to call it the base. You can also write it as f of x equals b to the x power. Either way, y equals or f of x equals, they're both the same thing. But b stands for base, and that base number is pretty important. Now we're going to write some more notes around this, so leave some space in your notebook next to this. And we're going to try some examples, and then we're going to come back and add notes, like kind of in this section. So leave yourself a little bit of room, but here is our question that maybe you can put underneath this. How does the base affect an exponential function? How does that number where the b is affect the graph? So then we're going to figure that out by doing some actual graphing. So here's example 1. We're going to graph a system. Graph this system. F of x equals 2 to the x power, and w of x equals 3 to the x power. Now we're going to graph them together on one graph, hence the system, and we're going to do it by building some tables. So I'm going to make two tables, one for f of x and f of x, and one for x and w of x. And for each of them, I'm going to do my usual go-to numbers. I'm going to do the -2 to +2. So let's do f of x first. -2, -1, 0, 1, 2. In your notebook, make a nice table just like I am. And then what we're going to do is we're going to take those numbers and put them in the function. So if it's 2 to the x power, we're going to do 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the second power. We got to do the math for each of those. Good thing we know our powers pretty well now. We know negative powers mean they're in the wrong location of the fraction. So 2 to the -2 is actually 1 over 2 squared. 2 squared is 4, so 1/4 is our first answer. 2 to the -1 would be like 1 over 2 to the 1, which is just a half. What's 2 to the 0? Anything to the 0 power equals 1, remember? What's 2 to the first? Well, just 2. And 2 squared is 4. So here's our numbers. They go 1/4, 1/2, 1, 2, and 4. Perfect. We got our first table made. Okay, let's make the second table for w of x. So we're going to go -2, -1, 0, 1, and 2 in our table. This time it's 3 to the x power, so it's 3 to the -2, 3 to the -1, 3 to the 0, 3 to the 1, and 3 to the 2 power. 3 to the -2 means it's really 1 over 3 squared, and 3 squared is 9, so 1/9. 3 to the -1 is really 1 over 3 to the first power, which is just a third. And what's 3 to the 0? Anything to the 0 power equals 1. 3 to the first is just 3, and 3 squared is 9. So here's our numbers. It goes 1/9, 1/3, 139. All right, now here's the work. We've got the two tables made, all of our values found. Now we're going to build our graph. So we're going to set up a big XY axis. Definitely use your ruler and make this neat and nice, because when it's a system, especially these ones with these numbers so close together, it's going to be hard to tell the difference between where the points are at. I'm even going to use two different colors to kind of show f of x versus w of x. I put my scale numbers on my graph. I'm just setting it up as neat as I can. Now let's put the points on there. So I'm going to start with f of x first. We're going to plot -2 and 1/4. So here's -2. I'm going to go up to 1/4. That's just a tiny bit up. I'm barely going to move my dot. Then I'm going to go to -1.5. Well, there's -1. Let's go up to the halfway point. I'm going to go to 0 and 1. Here's 0. I'll go up to 1. All these points are so close together. Then I'm going to go to 1 and 2. 1 up to 2. And then lastly, I'm going to do 2 and 4. So I'm going to go to 2 up to 4. And there it is. You slowly can see that exponential curve. So I'm going to connect those points with that nice smooth curve. No using my ruler for that piece of it. And there's f of x. Okay, now we got to add to the graph. We've got our f of x. It's a nice curve. We got to do w of x. So now we'll work on plotting that. -2 and 1/9 is the first point. So -2 is here. 1/9 is like just barely inching up that dot. -1 and 1/3 would be like -1, just a little bit up above that. 0 and 1, well, that's where the other point was for the other graph, so that's right there. 1 and 3, okay, so here's 1 up to 3 would be right there. And then the last point's at 2 and 9. So 2 all the way up to 9 would be way up there. So connecting those points with a smooth curve looks more like this. And there's our graph. Okay, so they look very similar to each other. They're just slightly different in numbers. Here's f of x, here's w of x. I'm going to label them. And then we're going to save this graph and come back to it. So I hope your graph looks nice and neat because we're coming back to it in a few minutes. So save everything. But we're going to add an example 2 to the notebook. So here's example 2. We're going to graph a second system. This time, the system we're going to graph is going to have some fractions and decimals involved. We're going to graph h of x equals 1/2 to the x power, and g of x equals 0.4 to the x power. So now we're going to do fractions and decimals. The other graph had whole numbers. So same story, I'm going to be making 2 tables, one for the h of x and one for the g of x. So set yourself up with 2 nice looking tables. I'm also going to do my normal numbers in both tables. So I'm going to work on the h of x first. I'm going to zoom in on that. I'm going to do -2, -1, 0, 1, and 2. Now this is going to be trickier because it's 1/2 to the x power. So I have to do a half to the -2 power. I have to do a half to the -1, half to the 0 power, half to the first power, half to the second power. Ugh, ugly, but we can do it. So what is 1/2 to the -2 power? Well, that's really like 2 squared. You got to flip the fraction. Remember, negative powers mean it's in the wrong location, and 2 squared is 4. So 1/2 to the negative power, if I flipped it, would be 2 to the first, which is 2. 1/2 to the 0 power, what's anything to the 0 power? 1 equals 1. 1/2 to the first power is just a half. And 1/2 to the second power is like 1 over 2 squared. That's 1/4. So here's our numbers. It goes 4, 2, 1, and then we get a half and a fourth. Okay, let's do the same thing with g of x. So we're going to go -2, -1, 0, 1, and 2. This time we've got 0.4 to the x power. So we've got to do 0.4 to the -2, 0.4 to the -1, 0.4 to the 0, 0.4 to the first, and 0.4 to the second. And how you do this is kind of up to you. You could use a calculator, you could change it to a fraction. It's kind of your choice. 0.4 to the -2 is like 1 over 0.4 squared. So 0.4 squared, 1 divided by 0.4 squared is 6.25. Now, you might need to practice putting that in your calculator to make sure you can do that yourself. Because if this was on a test, you'd need to be able to do that. So I would probably tell you right now, I would pause the video and make sure you're comfortable doing that in your own calculator. 0.4 to the -1 is like 1 over 0.4, so you type in 1 divided by 0.4 and you get 2.5. 0.4 to the 0 power is just 1. 0.4 to the first power is just 0.4. And 0.4 squared is 0.16. So there's our table values. Oh boy, so we got to take these 2 tables with these kind of ugly numbers and we've got to graph them again. So we're going to grab our ruler and build a second graph, exact same size as the first graph that we did. We're going to scale out our numbers, make it nice and neat, and then we're going to plot our points. If I'm going fast, pause the video. We're going to start with the first point for h of x is -2 and 4. So I'm going to go to -2 up to 4. Then I'm going to do -1 and 2. So here's -1 and 2. Then I'm going to do 0 and 1, so 0 and 1. I'm going to do 1.5, so 1.5. And I'm going to do 2 1/4. So 2 1/4 would be just a tiny bit up. And it looks, you can see that exponential curve again. There it is. We're going to connect it nice and smooth, looks like that. There's h of x. Now let's do g of x. G of x starts at -2 and 6.25. So I'm going to go to -2, and I'm going to go up to 6.25, which is about there. Then I'm going to do -1 and 2.5. So -1, 2.5 is like halfway between 2 and 3. I'm going to do 0 and 1. No problem on that one. I'm going to do 1 and 0.4. So that's going to be a little less than half. And then 2 and 0.16. So I barely am going to go up. And there it is. There's my point. So I'm going to connect those with a nice smooth curve. Oh my gosh, they're so similar. Look at those two curves are very close to each other. I'll label both of them to make it clear. So the first one, or the blue one, is g of x is equal to 0.4x, and the other one was h of x equals a half to the x power. Okay, so now we've got two good looking graphs, two systems. So now we got to go back and answer our question. How does the base affect an exponential function? So here are the two graphs. What do you notice about them? What observations can you make? Well, the first system was 3 to the x power and 2 to the x power, and look, both curves are pointing in the upwards direction. The second system had fractions and decimals, and the curves are both going in more of a downwards direction. Well, there's a reason for that. The base number tells you something. When they're fractions and decimals, look what the curve does. When they're whole numbers, look what the curve does. You have to pay attention to what those base numbers are doing. So here's what we're going to write back in our notes section. We're going to make two big bubbles here. In the first bubble, I'm going to say if our base is between 0 and 1. So if 0 is less than b is less than 1, that means it's a fraction or a decimal. It's between 0 and 1. If you have a fraction or a decimal between 0 and 1, then the graph exponentially decays. We call it decaying because it goes in that downwards direction. Decaying means it drops. If the base is greater than 1, if b is bigger than 1, it's a whole number, then the graph exponentially grows and it goes in the upwards direction. So we call graphs that drop down exponential graphs decay or they grow. Those are the two differences. And the base tells you what it's going to do. If the base is a small decimal fraction, it's going to be a decaying graph. If the base is a whole number bigger than 1, it's going to exponentially grow. I guess it doesn't have to be a whole number, just any number greater than 1. I gotta re-clarify that. Okay, so let me show you something here in a minute. I'm gonna write the base decides growth or decay. That's kind of our main idea. Now, going back to our graphs here, what is something else that you noticed about them? What was something that was the same on all four of them? On f of x, w of x, h of x, and g of x. Oh yeah, the y-intercept was always at 0, 1. Did you notice that? Why is that? Why are they all at 0, 1? Because anything to the 0 power is 1. So that's something you could kind of circle and highlight on your graphs. Okay, so now I'm going to give you 5 questions. And for these 5 questions, we're not going to draw any more graphs. We've graphed enough in our notes today. But what we are going to do is we're going to decide, is it a growth problem or a decay problem? If I was going to graph it, how would I label it? So here are your 5 problems. F of x, y equals, h of x, y equals, and f of x. Hit the pause button, copy them down, hit the pause button, and I want you to write next to each problem a guess. Is it a growth problem or a decay problem? Go. Okay, so growth or decay. Let's look at number 1 here. The first one has 0.5 to the x power. That's a base that is a small decimal. That's a decay problem. The second problem has 4 to the x power. That's greater than 1. That's a growth problem. Number 3, it has 3 to the x power. There's another growth problem. It's got a number greater than 1. Number 4 has 2.5 to the x power. 2.5 is a decimal, but it's greater than 1. It's a bigger decimal, so it's another growth problem. And then the last one has a fraction, 7 halves, but what's 7 divided by 2? Isn't that 3.5? So that's still greater than 1, so that's another growth problem. So if I was to graph all of these graphs, only the first one would decay. The rest would all be growth problems. Alright guys, so that kind of wraps up our video here. This is the big idea. The takeaway today is if you look carefully at the exponential base, the base number tells you the direction of the graph, if it's decaying or if it's growing. So pay very close attention to that number. Thanks guys for watching. I'll see you in the next video.